In this video, we're going to take a look at how to calculate the molecular formula of a gas given some information about the percent composition of that gas. So if you remember from Unit 3, you'd have to find an empirical formula first, and then you'd have to find the factor between the molecular molar mass and the empirical molar mass, and then you'd multiply that empirical by that factor, and you would get your final molecular formula. So this kind of forces you to review the finding molecular formulas from empirical formulas from Unit 3 a little bit. So remember, we have a gas made up of 80% carbon and 20% hydrogen. So we're going to find our empirical formula first. So empirical formula step. We do we assume 100 grams. So we're going to say that carbon has 80.0 grams there. And hydrogen, we're going to say, is about 20.0 grams there. And so we're going to divide by our molar masses. So 12.01 grams per mole here. Cancel that. Divided by 1.01 grams per mole. Cancel that. And we're going to get, so we have 80 divided by 12.01. And we're going to get C 6.66111. So 661115737. And then H is going to be 20 divided by 1.01. And we'll get about 19.8019802. And don't forget that's in moles. But I'm not going to continue writing the units because don't forget our next step. So this is sort of our empirical formula, step A. Step B is going to be divide by small. So we'll divide by the carbon value, 661115737. Same thing over here, 6.661115737. And so we're going to get C1H, so that divided by 6.661115737, about 2.97. This is in the roundable range, right? It's roundable already. We don't have to multiply by anything. We can just say, therefore, the empirical formula is C1H3. So we found our empirical formula. Great. Our next step is let's find the molar mass of the empirical formula. So molar mass of the empirical formula is equal to the molar mass of, CH3, which is equal to, so it's 12.01 plus 3.03, because there's 3 hydrogens there, 15.04 grams per mole. So we have our empirical formula. We have our molar mass of our empirical formula. Now we need the molar mass of the molecular formula. And we can find that because we have it as a gas. So 4.6 grams of this gas occupies a volume of that at 1.5 atm and 25.0 degrees Celsius. Find the molecular formula. So we need to find the molar mass of the molecular. We know the following. We know the molar mass we got from our formula up here is mass times R times T divided by PV. So MRT over PV. We have the mass, 4.60 grams. We have the temperature. It's 25 degrees Celsius, but it has to be Kelvin, so 298.15 Kelvin. We have the volume is 2.50 liters. And we also have the pressure. Now, the problem is the pressure is in ATM. So the pressure is in ATM, and there's 2 things you can do. So remember, we need R. R is equal to 8.314. We have kilopascals, liters per mole, Kelvin. Okay, that's our unit that we've been using all along for the R constant. So kilopascals, liters per mole, Kelvin. So that means that the pressure we need to use has to be in kilopascals, not ATM. So there's 2 things we could do. We could go and select a different R constant. So for example, I can go to my table here and select the R constant that has the ATM in it. So liters, ATM, Kelvin mole. This one would work, 0.02057. Or we can convert our ATM to kPa. Either one will work. You can try that out using this R value instead of the R value there, or converting. I'm going to go ahead and convert. So I'm going to say 1 ATM is 101.325 kPa. So that means I need to multiply my ATM by 101.325. So just to show you the work here, I'm going to do 1.5 ATM. Let's do it over here. 1.5 ATM times 101.325 kPa for every 1 ATM. Cross out ATM, and you get, so 1.5 times 101.325, and you get 151.9875 kPa. So now we have our kPa value for pressure, and we can find that molecular formula, molar mass of the molecular formula. So we can do our mass, which is 4.60 grams, multiply it by 8.314 kPa liters mole Kelvin, times our temperature, which is 298.15 Kelvin, over the pressure and volume. So the pressure is 151.9875 kPa, and the volume is 2.50 liters. We can cancel out liters, we can cancel out kPa, we can cancel out Kelvin, and we're left with grams over mole, which is our molar mass. So what we wanted. So let's go ahead and do that. 4.6 times 8.314 times 298.15 divided by 151.9875 divided by 2.50, and we get 30.000922539 grams per mole. So we found the molar mass of the molecular formula. That's what we're looking for there. That's our step 3. So notice there's a lot of steps here. You do need to practice your concepts from previous units. So before you attempt this, go back and take a look at empirical and molecular formula steps to make sure you understand that. So our step 4 is going to be to find that factor, that multiplying factor. We called it A back then. It was the molar mass of the molecular divided by the molar mass of the empirical. So it was at 30.0092259 over the 15.04 grams per mole. And those cancel out. And we get a factor of, it's probably going to be about 2, so 15.04, 1.99, or approximately 2. So we have that multiplying factor. So now all we have to do is do 2 times our empirical formula, which is CH3. I'm going to put a 1 here so remember we're multiplying everything in there. So times 2, and we get C2H6. So therefore, the molecular formula is C2H6. Now you don't know this yet, but this is something called, if we draw this out as C2H6, if you were to draw it out like this, you would do your Lewis structures. You might call this dicarbon hexahydride, but in grade 12, you'll learn that this is an organic compound made of a whole bunch of carbon hydrogens, and it has 2 carbons. And so the name when something has 2 carbons is eth, and there's only single bonds there, so we would indicate that by ethane. So that's what that is. This is actually called ethane, and that's the molecular formula there for ethane. So this was a nice question because it really forces you to kind of go over your mole calculations, your empirical formula, your molecular formula, your molar masses using the PV is equal to nRT. So everything's kind of thrown in there, and it shows you that all those skills you learn, they're not isolated skills, but they're skills that you'll be using going forward together. So you can check your answer obviously in this video because you're watching it now. You can also take a look at the answer in this little slide deck over here. So we can see it's C2H6, and there's another method of doing it here. Very similar, just organized in a different way. So take a look at this if you need a different organization, but it's the same answer in the end. In the next video, we're going to do a new type of problem involving PV is equal to nRT and density. So we'll take a look at a few steps involving that. But before you go to the density problems, make sure you can do the basic PV is equal to nRT. Make sure you can do PV is equal to nRT and molar masses, along with the extension of molecular formulas from molar masses and empirical formulas.